All right, for this Flipgrid, you're going to end up having to make two videos for rational word problems. You're going to explain a shared work problem as well as a distance equals rate time problem. So here we go. John can wipe all the desks in a classroom clean in 35 minutes. Alice can wipe them all clean in 43 minutes. When they work together with their friend Scooter, it takes them 10 minutes. How long does it take for Scooter to wipe that desk on his own? All right, so this is going to be our shared work problem. Okay, so when we do a shared work problem, we're going to be thinking about the unit rate. Okay, and we're going to be making unit rates. How much can they get done in an hour or a minute and so forth? So we know that John can clean it in 35 minutes. So his unit rate is 1/35. And this is John. We know that Alice can clean the desks in 43 minutes. So her unit rate is 1/43. And then they're going to be working together with Scooter. And we don't know Scooter's unit rate because it really doesn't tell us anything about Scooter other than the fact that he's helping. So what I'm going to say is okay, well, Scooter is our unit rate of 1/x. And we know that they're going to work together. So because they're going to be working together today, we're going to add their unit rates together. We're going to add their work together. And when we add their work together, so John, Allison, and Scooter, we know that combined, it only takes them 10 minutes. So the combined unit rate is going to be 1/10 minutes. Now, at this point, we're just going to go ahead and take our two sides of our equation. We're not going to do anything algebraic for this. We're just going to go ahead and use Desmos. We're going to plug those in to Desmos. I'm going to take, okay, so let's go in here. I'm going to plug in my 1/35 plus 1/43 plus 1/x. I'm going to type in the other side of the equation, y equals 1/10. And we're going to look for that intersection. And you'll notice that somewhere around there, I'm going to come out here. Their intersection is at 20.75. So let's go back out here. X is going to be equal to 20.75. Well, what does that mean? That just simply means that this is Scooter's time to be able to clean the room on his own. Okay, whoops, I'm having a hard time writing Scooter. Okay, so that's going to be Scooter's time on his own. Okay, so that's going to be our shared work problem. Okay, and then let's go ahead and come down to a distance equals rate times time problem. So I'm going to write that down, or distance equals rate times time. And I'm going to make sure that I've got a diagram for this one. A boat that can travel 36 miles per hour in still water is driving up a river to the marina. So we have a boat. Okay, let's go ahead and draw this boat. Nice boat. Here it is. Okay. And this boat is going to be going upstream. And then it is going to be turning around downstream. Okay. It says a boat that can travel 36 miles per hour in still water is driving up a river to the marina. So we know that its rate on its own in still water is going to be 36 miles per hour. Okay. And it's going to go up the river to the marina before it travels back down the river. It travels upstream 30 miles. So we know its distance is going to be 30 miles. Okay. It can travel that 30 miles in the same time it can travel 40 miles downstream. So in the downstream current, its distance it can go is 40 miles. But notice it gives us a hint about how to do this problem. It says in the same time. So what that means is the time upstream is going to be the same as the time downstream. So it gives us some information. It says the time upstream is the same as the time downstream. Well, how do we find time? Well, if we want to find time, we just divide by the rate. So time equals distance over rate. So we know the distances. Now we got to figure out, well, what is the rate? It says, how fast is the current? That's going to be our question. How fast is the current? So when we're going upstream, does the current help or hurt? Well, it hurts it because we're going against the current. So really, as it's going upstream, its rate is going to be 36 minus the current, which we don't know, which we're going to say is x. But then it begins to go downstream, and that current is going to help the boat go faster. So its rate is going to be 36 plus x. Okay. Now we go back to this statement right here. The time upstream is the time downstream, and the time is distance over rate. So I'm going to go ahead and set that up now. I'm going to say, okay, well, the time upstream, what is the distance upstream? It is 30 over its rate of 36 minus x, and that is equal to the time downstream. Well, it goes 40 miles downstream with a rate of 36 plus x. All right, so let's go ahead and we plug this into Desmos. I'm going to come back over here, go into our graphing program, and I'm going to type in that. I'm going to type in the next one. I'm going to go back to the home screen. I'm going to look for where they intersect because that's where they're going to be equal. And you'll notice what it says. It says x equals 5.14. So x equals 5.14. And what does x represent? X represents the current. Okay, so that is going to be the current. Okay, so the current is going to be 5.14 miles per hour. All right, y'all, those are the two problems you're going to be explaining. This is a walkthrough on kind of what I'm expecting. So you're going to want to make sure you have the equations. You're going to want to make sure that you've got a graph of the distance equals rate times time problem that you make. You're going to want to make sure that you solve all your work in Desmos. You do not need to do it algebraically.